So we're here at the residence in Utah, flown in, all expense paid, limo transportation to this very nice hotel, and right now just kind of getting ready to go down and meet some of the leaders within the company, and I will update you in a little bit.
Every cell in the body, we have between 13 trillion and 100 trillion cells, living cells in our body. Well, how many do we have? Depends on the scientist. Why don't they agree? It's too many to count. Any way you want to count it, they can't count. Okay? So they just say between 13 trillion and 100 trillion living cells. Now, inside every cell, of course, we have the mitochondria. Mitochondria is the brain of the cell. You thought you only had one brain. Do you know? Man, if you knew what I knew about the human body, and you didn't believe that God exists, by the time I get through with you, you'd believe it. Because it's not one miracle or 10 miracles. I mean, it's millions and millions of miracles. And here's one of them. 13 trillion brains. Figure that out. Now watch what happens. The mitochondria produces a substance called ATP. ATP gives the cell energy. Why does it need energy? To function. White blood cells, the more energy they have, the more they can protect your body from disease and infection. Muscle cells, the more ATP, the more energy they have, the more effectively and efficiently they can work, and the faster they can recover from work. Recovery, that's huge, okay? Depending on how much ATP they have. Okay, a little fire inside the cell. Now, if that wasn't extinguished, then the production of ATP alone would kill the cell. We all die real fast. But God knew better, so He gives us this incredible miracle protein. It's actually 3 proteins in one molecule. How hard is it to produce that in a usable form for the human body? It's a 100-step sequential electrochemical process. One step out of sequence, no glutathione. One step short, give me 99, no glutathione. This presents a real problem to people that believe in evolution, because how did it evolve? It had to be all 100 steps in sequence the day the human cell or any cell of any mammal was created. Had to be there, folks. Amazing but true. Now, so this little guy here is the world's best fire extinguisher, and it handles this flame all the time, no problem. But it not only handles that, it handles all the oxidative attacks from free radicals. Now, a free radical is just looking for one thing, and that's a free electron that it can steal from the cell. And it needs that for it to get strong and survive. But when it takes that away from a cell, it damages the cell and leaves the cell vulnerable for attack. What happens? A little thing called cellular inflammation. Why is that bad? Because inflammation is the primary cause or the primary contributing factor to aging and every single disease of aging. Okay? So, but God's smarter than free radicals, thankfully, and this little glutathione not only handles this internal flame, it handles that better than any antioxidant known to man. In fact, let's take our best antioxidants, vitamin E and vitamin C. One molecule of C has 5 free electrons, a vitamin E molecule has 3. So one molecule of C can handle 5 of these guys. One molecule of E can handle 3 of them. Glutathione has millions and millions and millions of free electrons. So it's millions of times more powerful than either one of these, which means until we turn about 20, it's very effective at handling inflammation and oxidative attack from free radicals. So it's very cool. Every cell has 2 other protectors that are enzymes. One's called catalase and one's called SOD. Okay, so that's how God protects the cellular structure from both internal oxidation and from attack. Now, problem is, make some space here. So everybody got that. And you don't have to repeat that. We're not going to test you on it. But the problem is, starting at the age of 20, all the way through the age of 80, our glutathione levels, the production of glutathione by the liver and every cell in the body declines. And it declines by about, we'll say that's 30, declines by 15% per decade, roughly. Between 8 and 15%. In our environment, I'm sure we max it out at 15. And so that you have a 50-year-old, best case, has 45% less glutathione than they did at 20. Now, what does less glutathione mean to the cell? It means a couple of things. Well, first of all, there's not as much glutathione to handle this problem. So, the mitochondria, rather than overwhelm the cell with oxidation and destroy the cell, turns down the thermostat and produces less ATP. But it lowers it to the point where glutathione can handle it. And what you have left can handle it. So that's a good thing. The bad thing is less ATP means less what? Energy. Less energy. So it means red blood cells don't have the energy to give all the oxygen to the tissue. It means white blood cells don't have the energy they need to fight off disease and infection. It means brain cells don't have as much energy to focus, retain, and access information. It means muscle cells get tired more quickly and take longer to recover. Now, can anybody over the age of 20 identify with me on that? Okay, yeah, thank you. I'm not the only one. And I wasn't ever an athlete, so anyway. But on top of that, there are a lot of things that deplete our daily reservoir of glutathione. For example, when you exercise, the first 10 minutes of aerobic exercise, you will use up 40% of your muscle's available glutathione. When you cross over the 60%, which isn't far beyond that, you then go into what's called anaerobic glycolysis, which means that the cells in your body begin to burn sugar without oxygen. That creates lactic acid. Lactic acid is destructive to the muscle cell and makes you sore, okay? It makes it hard to recover the next day. Why? Because now it's got to repair itself, which is okay, the body's built to do that. But if I had the choice of having something damaged and having to go through the repair or not damaging it in the first place, I'd rather not damage it in the first place.